I'm Charles Conway.
Hey guys, I'm Ohan Manoukian, and
This is our circuit.
we're going to present our ECE2001W laser audio transmitter circuit.
This is our transmitter circuit, and basically what happens here is the battery inputs some voltage in here when we plug it in right there, and we have the phone hooked up to the circuit, and we have a microphone right here, and the phone inputs a signal that travels through these wires to the potentiometer so we can control the volume. It then goes through a capacitor to block all DC voltage. Then we have some resistors here that connect to this OP amp. So this resistor with these resistors forms the gain, the RF over these resistors right here. And over here on the mic, we have the mic which receives a 5-volt signal to activate it, which comes in through this over here, which actually comes in through this voltage divider, because as we see we have a 9-volt battery. So we have to use a voltage divider in order to split it up. This is the ground right in the middle. We use these two capacitors to stabilize the divider. And on this side we'll have a positive 4.5 volts, and this side we have negative 4.5 volts. So, or the other way actually, I'm sorry. This side is negative 4.5 and this side is positive 4.5. So this travels up here and actually inputs technically 4.5 volts into here, which is good enough to make it work. And then the signal travels through the potentiometer so the volume can be controlled, through the capacitor so it can block all DC voltage, through this resistor, and this resistor forming the gain. So then goes through this OP amp, which has negative 4.5 volts on one side and positive 4.5 volts on the other side of the VCC. Amplifies the alternating current. It then travels through here, through this capacitor to again block any DC voltage that it might have picked up in the OP amp. Then over here we have the bias T. The bias T works on the principle that we have, in our circuit we actually have the full 9 volts flowing in through here, through the inductor so that the AC voltage can't travel this way, and then over here we have the capacitor also so that the DC voltage can't travel up that way. It then flows through this resistor and to the output into this laser.
Alright guys, and then the AC signal plus the DC offset that Charlie was talking about from the resistor comes in through this laser that you can see I'm pointing. And if you point it right at the solar cell actually makes a voltage difference when it shines its light. And move it over. The voltage comes in through here through these two capacitors to cancel out the DC. Resistor, which is the input resistor, and it goes into this op amp right here, which has a negative feedback to control gain. And again, just like the transmitter side, we have a voltage divider up here, which controls the positive and negative VCC biasing of the op amp. And then the amplified AC signal basically just outputs straight into just a regular computer speaker that we have. And you should be able to hear the microphone and audio signal that you transmitted across the laser. And we're going to show you a demo right now, so stay tuned. As you can see, the signal coming in through the iPhone is being transmitted through the laser across some distance to the solar panel, and it's being outputted through this speaker right here. As you can see, it's pretty clear, it's pretty loud. We can turn it up louder actually if we wanted to. Do a little bit. Yeah, so, and you can even talk into it if you want. Charlie wants to talk into it.
Hello? 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 Hello?
So you can...
I'll turn that up and I can turn the music down and the mic up.
And we can demonstrate the microphone some more.
Yeah, so I can turn this down and maybe turn this down.
So Charlie just basically turned off the music signal from the potentiometer on the transmitter side.
Hello. 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 Do you hear it through there?
Yeah. And you can hear him talking through the microphone, and that's basically it. So we created a mixer, an audio mixer, that transmits through a laser, so you can wirelessly play music. Not ideal for a house, but hey, it works, right? So anyways, that's Charlie, I'm Ohan. This is our ECE2001W design project.
Yep.
So thank you for your time.